So with the size of sets, we've talked about finite sets, and we've talked about countably infinite sets. This brings us to the third type of size we can get, and that's uncountably infinite. Again, we will never reach the end. We can never finish counting this set because it's infinite. And there is no clear pattern that would allow us to continue counting. One thing to keep in mind, these definitions are not strict, rigorous definitions. This is just for a basic understanding of finite, countably infinite, and uncountably infinite. If you want a rigorous definition, make sure that you go to a math textbook or research for a proper definition online. This is just to give you a very, very basic idea. Okay, so we're never going to reach the end, and there's no clear pattern that would allow us to continue counting. For example, our real numbers are uncountably infinite. I could go 0, 1, but then in between 0 and 1, there are infinitely many real numbers. There's going to be 0.1, 0.001, 0.00001. We could go on forever just between 0 and 1. And then we have the rest of the number line to deal with. And even between 0.1 and 0.2, there are infinitely many real numbers. So our real numbers fall under the size of uncountably infinite, as do our complex numbers. At this point, I just want you to have an idea of the difference, first of all, between finite and infinite, and then know that N, Z, and Q are countable, whereas R and C are uncountable. Alright, this brings us to our first example. We want to classify the following sets by their size, so classify them as finite, countably infinite, or uncountably infinite. Go ahead, pause the video, try to do this on your own first, and resume when you're ready to check your solution. For this first one in part A, we have Z, which stands for our integers. And we know from above that these are infinite, but they are countably infinite. Next, we have a set of just 3 numbers, so I could count those right now. We have -7, 2, and 39. That makes this set finite. Alright, in part C, we have an infinite set as indicated by the ellipses on either side. However, we have a pattern. We go from -12 to -8 to -4, 0, 4, 8, 12. We're adding 4 each time. If we wanted to, we could continue this pattern, or we could program a computer to continue this pattern and continue counting these numbers, which makes set C also countably infinite. D is the complex numbers. We've seen from above that this is uncountably infinite. For set E, the number of days in a month, hopefully you realize that with our calendar we can have either 28 days in a month, 29, 30, or 31, which makes this a finite set. There's only 4 possible numbers in this set. And then lastly, we have the reals, which are also uncountably infinite. And that does it for example 1. Next, we'll talk about set notation and more.